Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. This question comes from the 2024 Higher Level paper and it's question 6 part B. The acceleration of a particle moving in a straight line may be expressed in terms of its velocity v in meters per second and its displacement s in meters by the differential equation v dv ds, which we know is another way to say acceleration, is equal to e to the power of v squared over 4. Solve the differential equation to find an expression for v in terms of s, given that v equals 0 when s equals 0. So first thing we're going to do is we're going to separate this out. There's quite a lot going on here. So I have my v. I'm going to bring over my e to a power of v as well. Bring this down a bit. And that's going to be with respect to v. And then I'm just going to have my ds on the other side. If you want, you can write that as e to the power of a negative v squared over 4 if you're not a particular fan of your fractions. That's fine, and we can have our ds here as well. They told us that v is equal to 0 when s equals 0, and we're working to v and s. Now, the right-hand side, this is very straightforward. We are getting s and evaluating it between 0 and s. The left-hand side is a little bit trickier. So we do have a v and an e to the power of v squared over 4. So go to our checklist. Is there a formula on page 26? So there's nothing on page 26 that looks like this. Is it a composite function? And in this case, yeah, it is a composite function. So we are talking about integration using substitution. Now, integration by parts, you might say, oh, could I use integration by parts? It is possible. Well, it can be done. Do you have the time or the math skills to do it? That is a different question. How you need to be able to identify this is the fact that we have an e to the power of v squared over 4. And that is usually something like an e to the power of x. And if you think of it in terms of a composite function, imagine we have f of x is e to the power of x, and we have g of x is equal to minus x squared over 4. This could be written as f after g of x. So we put g of x into f of x, which is what gives us this. That's what we mean by a composite function. So this part here is a composite function. Don't worry about the other v. So for us to kind of think about it, I'll leave this here so you can kind of get a sense of it in terms of x. So we're working with the v. So what we have is we have something that's quite hard to work with. So I'm going to use this as a negative because of the way I've worked with it. If you had it underneath the line and it's positive, that's absolutely fine. This is called u substitution as well. So we're going to sub in a minus v squared over 4 as we're going to sub in u for minus v squared over 4, which makes that so much simpler. So what that's going to become is an e to the power of u rather than e to the power minus v squared over 4. But that's not everything, because we also need to deal with the fact that we have a dv. So because we have a dv, we need to differentiate this u to make a du dv and then split that out. So whenever you have your u, you then differentiate. So we bring down our power, take one away from our power, we are differentiating here. So that gives us du is equal to, it's minus a half v dv. Now, we have, I'm going to actually use a highlighter here, it might be easier to see. We want to replace a dv, but we also have a v here we want to replace. Now we have that here, but that minus a half is not helping. So what we're going to do is we're going to bring that to the other side. So I'll go back to my purple. So minus 2 du is equal to v dv. So we're going to change this v dv that we've highlighted into a minus 2 du. So what that becomes is, for a nice simple little integration, is e to the power of u minus 2 du, which is integrate minus 2e to the power of u du, which, very straightforward, is just going to give us the exact same thing. So minus 2e to the power of u. So e to the power of u is going to stay exactly the same. The minus 2 is just coefficient. It's not going to do anything. So when we plug this back in over here, we're going to change our u back to what we defined it as. So we get minus 2e to the power of minus v squared over 4. And we're going to evaluate this between 0 and v. So what we get is minus 2e to the power of minus v squared over 4 minus 2e to the power of minus 0 squared over 4 is equal to s minus 0. So that's gone. Just be careful. This piece here does not disappear because we have an e to the power of 0, which is actually 1, which gives us a minus 2. So just to give us a little bit more space to work, we get minus 2e to the power of minus v squared over 4 minus a plus, and that gives us a 2. Remember, this whole piece here is equal to 1, and that equals to s. What we're looking for is v in terms of s. So we need to get v on its own. So we get minus 2e to the power of minus v squared over 4 is s minus 2. Let's divide by that minus 2. I don't particularly like having a negative on the bottom, so I'm going to flip this to be 2 minus s all over 2. So you can think of this whatever way you want. If you divide by that negative first, so that flips the signs on the right hand side before you divide by 2. Whatever works for you. So then we take the natural log of both sides to get rid of that e. So we're left with minus v squared over 4 is equal to the natural log of 2 minus s over 2. Bring that 4 over. And then we need to bring over that negative as well. So v squared is negative 4 natural log 2 minus s over 2. Now, don't get freaked out about that minus because we're going to square root it, and then you think, oh, can I square root a negative? But that minus, that natural log will actually be negative. So that minus is needed to undo the negative of that natural log. So if you prefer, you can leave it like this. If you prefer, you can bring this negative as a power. So that's going to be like a power of negative 1, which effectively, if you have a fraction to the power of negative 1, so imagine you have like x over y and it's the power minus 1, it effectively gives you the reciprocal. It flips it. Okay, so we're going to use that fact here. So v squared is equal to 4 natural log. This then flips, so 2 over 2 minus s. So all it does is flip the fraction. It's the reciprocal. And then we're going to square root that. And I can pull that 4 out in front because the square root of 4 is 2. We can do that because it's multiplying. And we get 2 over 2 minus s. And that's velocity, so it's meters per second. And it will be absolutely fine if at this point you went straight. So here, if you went v equals square root of negative 4 natural log 2 minus s all over 2. And left it like that, absolutely fine. No problem at all. I just prefer that cleanup. I don't like the look of the negative underneath, but it's absolutely fine to leave it there. So part 2 says calculate the velocity of the particle when s is equal to 0.3 meters. So our answer for part 1 we have here in red, and we can plug our s straight in and then go to our calculator. So we don't need to go and find an earlier line in our previous calculation. We can use our answer. It's going to be very, very straightforward. We get 2 over 2 minus 0.3. Put that into our calculator and correct 2 decimal places, we get 0.81 meters per second. It's really important for questions like these that even if you think you have the wrong answer, or if you feel like you didn't even get it finished, plug that s equals 0.3 into whatever you have, because it is possible to get an answer for v even if you're incorrect in the previous part and get full marks. Equally, if you don't have a final answer V equals, you have something as S equals in the previous part, and again you still sub it in and you get an answer, you're still able to get full marks. At the very least, by subbing in an S equals 0.3 meters into something from your part 1, you will get a 10 mark.